G'day, thanks for watching another Pickaxe ProtoPlatform tutorial video. In this video we're going to have a look at the 7 segment display and driving that just from a Pickaxe microcontroller. Again, I'm using the 14 pin chip for all of these demos, but a 20 pin actually probably would be easier with the 7 segment display if you've got one. But on my code I've converted to be able to use the 14 M2, and I'll show you why that's a little bit more difficult on the screen. But first I'll just show you what it looks like. So we'll turn it on, does a quick check to make sure all the digits are working, and then counts up from 0 to 9 and has the decimal point as well. So I'm not going to pull this one apart and put it back together because the wiring's a little bit more complicated and it'll be hard to see from the video what's actually happening. So I'll just point out that it's a common anode, which means that you supply it with 5 volts, and then all of the other connectors, each of these connectors are pulling one of those segments down to ground, which is letting the current through and going down to the ground. So if I just quickly show you, I've got a 330 ohm resistor there. Now that value is a little bit over the specified value needed, but I found that I didn't put the resistor in before, and I blew out a few of those little segments and it stopped working. So it's really important that you do put a resistor in, and I've got the 330 ohm resistor, and coming from that 4.5 volt battery box. Seems to be the right amount of brightness, so the intensity is pretty good, but it's not too high voltage that it's blowing out those segments, so that value is pretty good. Like I said, each of these wires are connected to one segment. It's a bit hard to show you while it's counting up like that, so I won't do that, but instead I've drawn a few pictures and I'm going to show you them, and then we'll have a look at the code on the screen. So I'll turn that off. Now this is a SparkFun 7 segment display, and like I said before, it's common anode. So I've had a look at the data sheet, but apparently the data sheet's wrong, and it's probably more confusing looking at that than it's worthwhile, so I thought I'd just draw it out for you. There's 10 little pins on the back of the 7 segment display. I'll pull that out and show you. So there's 10 little pins there, and each of those pins I've got represented as a little circle. I'll just leave that out. And the middle pin on both the top and the bottom is the common anode, so that's where I'm supplying the power to. So it's important that you put the 5 volt power to not just the one, but also the other one as well. And you could even put a little jumper wire. I've got a wire going over top of mine on here, so my power's coming into this rail and then I'm going to the two spots, but I could have actually put a little jumper wire underneath the 7 segment display. I just didn't think of that. Now, I've used the same lettering as the data sheet for each of the segments. So it's starting up here, and I've got A, B, C, D, E, F, G, and then there's the little decimal point there, which they call DP. Alright. So like I was saying, each of those pins connect to one of these segments. So this first pin here, I'm not going to call them any numbers because I think the numbers are probably wrong. That one is connected to the decimal point, so that's to here. You can imagine if that was an LED, there's 5 volts coming down to that LED, and then the other wires coming out to this pin, and when we pull that pin down to ground, so we ask B0 to go to a low command with our program, the decimal point will come on. If I keep going around, so I've got A, B, C, D, E, F, G, and G's in the centre there, and I've modified this code. I've written this specifically for the ProtoPlatform, and I've tried to make it easy so that the wires go straight out to the header pins, so it sort of makes sense to work around. So I've got, starting from B0, then B1 is the C segment, so this one, B2 is the D segment, B3 is the E segment, B4 is the F segment, which is this one, B5 is the G segment, that center one, and then C0, pin C0, which is on the opposite side of the microcontroller, so that's the left hand side of the microcontroller, but starting at the bottom, which is that blue lead here, that one. So they're all the B pins, and these are all the C pins on the 14M2, is connected to A, and C1's connected to B. So hopefully that pin out gives you a bit of help to show you what the pins are connected to, and shows you how I've connected them. And in the code I've actually labelled them. For example, this one's Seg A, which is C0. Now over here I've showed you how I worked out what segments I turned on to get each number, and I've used 2 for an example. So for the number 2, obviously a 2, you can't get round curves like that, so you have to have straight lines, and that's the best you can get a 2 to look like on a 7-segment display. So for a 2 to work, I had to turn off. So you want all of the pins to be high pins, except so when they're all turned on high, it's a bit hard to grasp to start with, but when they're all high, the voltage from the common anode can't get through, but then when you turn them low, the voltage does go through, and then they light up and go red. So when they're high, it means they're all off, and when they're low, it means they're on, which is a bit confusing, I guess. So to make a 2, I needed segments A, B, G, E and D to be low, and if we have a look over the other side, that's A, B, G, E and D all needed to be turned low, and the other ones had to be turned on high. So that was the same as saying low C0, C1, B5, B3 and B2. Now that would be hard to write in each of my code, and it would be a bit hard to think about, and a bit of a cleaner way to write that is to say that let pins B, and this is a pickaxe command, pins B with a percentage symbol, and this is in binary, but this first digit to the furthest to the right is a 0, and that's 1. So this is B0, B1, B2, B3, B4, B5, but B6, 7, it should be 8, sorry. So 0, 1, 2, 3, 4, 5, 6, 7, and I've missed a number on that one. There should be 8 digits. I'll just quickly look that up. So the 2 was 1, 1, 0, 1, 0, 0, 1, 1. Oh, sorry, there is 8 digits. So it's 0, 1, 2, 3, 4, 5, 6, 7. Of course that makes sense. I just got a bit lost there. So there's 8 digits there, but they start from 0 to 7 rather than 1 to 8. And then the same, likewise here, this is C0 and this is C7. Now, in binary, that number there happens to equal, the first digit is a number 1, and the second digit is 2, and then this third digit is 4, and then 8, and then 16, and 32, and so on, 64, and 128. So if you add up all of the ones, this equals 211, and if you add up all the ones in here, it equals 255, and the highest number, if all of these were ones, it would be 255. If all of them were zeros, it'd be 0. If it was just one on the end, so it was 0, 0, 0, sorry, 0, 0, 0, 0, 0, 0, 0, 1, that would equal 1, and if it was, these were both ones at the end, it would equal 3. Do a bit of research on binary if you didn't quite understand that, but really basically what I've done in the pickaxe program is I've put this in the comment section to show how I got to the figure, but then I just use numbers so it's easier for you to copy out to use in the program if you like. So we'll have a bit of a look on the screen now, and in this code I've got very much the same at the top, saying it's for the 14M2 again, and I've got the 7 segments hooked up. So decimal point was hooked up to B0 like I said before, then C, D, E, F, G, and then A, B back up the other side. Now, like I was saying before, it'd be simpler if you used a 20 M2 microcontroller, because you wouldn't have to use any of the C pins. You could keep on using the B pins, because there's on the 20 there'd be a B6 and a B7, which means you would be able to use segment A and B on 6 and 7, and then you'd only need to use one line of code for each of these, let pins be equal, and you have to figure out a new number there rather than having two lines for each digit, or each digit. So in the code I'm just saying pause for a second. This is first saying change the direction, so this is saying let the direction of all the B pins equal 1, which is make them outputs. So here make B0 to B6 outputs, and this one's make C0 to C6 outputs. And then it's saying turn off all of the outputs, so make all of them low except for that B7, which doesn't exist, and C7, which doesn't exist either. So it's turning all of those pins to low, which makes the whole 7-segment display light up, each of those seven segments on there. Then we're pausing for a second, and this is just acting as a counter. So the B0 is a memory variable. To start with, it equals 0, and it's saying 0 plus 1, which obviously is going to equal 1. So if B0 equals 1, then we're going to go down to show 0, and that's going to be the first thing that happens. So in each line I've got let pins be equal 255, or whatever the number is. You don't need to have 255, you could just have that binary information, but that equals that 225 that equals. So I think the numbers are easier to look at as long as you understand how they were derived. So each of these here are the binary numbers, and this is what the binary number actually equals in a decimal form. Yeah, that's about it. So thanks for watching this video on the 7-segment display. Hopefully you've been able to understand a little bit, and good luck getting yours working. Cheers.